Hello, in this video I'm going to be showing you a proof to the product rule. And so for this video you are going to need to know how to do differentiation from first principles. And so if you've either forgotten or you just don't know what that is, then I'll link the video I've made on that in the description so you can go and watch that video, then come back and see this one. And so very briefly, we're going to use the product rule if we want to take the derivative of a function, so for example h of x, which is made up of the product of two other functions, so say f of x multiplied by g of x. And so an actual example of this could be a function, say h of x, which is equal to e to the x multiplied by another function, sine of x. Okay? And the formula to take that function's derivative is given by the product rule, which is that formula there. And in this video we're going to show you how to get it. So, to start off with, we want the derivative of h of x, which is just equal to f of x multiplied by another function, g of x. Okay, so nothing crazy so far. Well, we could say this is equal to, using differentiation from first principles, this is equal to the limit, as delta x is going to tend to 0 of f of x plus delta x multiplied by g of x plus delta x, subtract the function f of x multiplied by g of x, and that's all going to be divided by delta x, like so. So now we can actually utilize a trick in maths, okay? And so what that trick is, well, say as an example I had the number 4, I then add 1 to 4, and then immediately subtract 1. Well, this is still equal to 4 because I haven't added or subtracted anything. I've technically added or subtracted 0 because, well, 1 subtract 1 is 0, right? And so we're going to use this same logic to rewrite this to help us manipulate the algebra a bit. And so we could say this is equal to the limit, as delta x is going to tend to 0 of, well, the start is going to be the same. We've got f of x plus delta x multiplied by g of x plus delta x. But this is what's different. I'm going to subtract f of x plus delta x multiplied by g of x, and then I'm instantly going to add it back on. So plus f of x plus delta x multiplied by g of x, and the last part is going to remain the same, so subtract f of x multiplied by g of x. Okay, and you'll see why I've done that a bit later on. So this is still all over delta x and it's still the same thing. From here I'm now going to split this up into two fractions because they're over the same common denominator, so I can do that. And so I've got, well, this is equal to the limit, as delta x tends to 0, I'm going to put it in brackets just so I'm taking the limit of everything, is still quite clear. And so we're going to take this first part to be the same, so f of x plus delta x multiplied by g of x plus delta x. Then I'm going to subtract f of x plus delta x, this is the part that was in red above, I've now continued to write it but in black, and that's all over delta x. And then I'm going to add on this second part, so f of x plus delta x multiplied by g of x, subtract f of x multiplied by g of x, and that is all over delta x also. So from here, okay, I can distribute that limit across the two terms. So we can take the limit as delta x goes to 0 of this first term, and then add on the limit as delta x goes to 0 of this second term. Okay, and that's all I'm going to do. I'm just going to write that out. So we've got the limit as delta x is going to tend to 0 of, well, this first part here, like so. So let me just bring that down. And then we're going to add on to that the limit as delta x tends to 0 of this f of x plus delta x, g of x, subtract f of x, g of x, all over delta x, like so. Okay. Now there's one final step sort of before we're there, and what I'm going to do is on this first term, or this first part here, I'm going to factorize out this f of x plus delta x. Okay, and so if I do that, we're going to get something that looks like this. We've got the limit as delta x tends to 0 of, well, I've got f of x plus delta x, and because I've factorized it out, it's going to be multiplied by g of x plus delta x minus g of x, all divided by delta x, like so. And in this second term, so in this second limit as delta x tends to 0, I'm going to factorize out this g of x from those two terms. And if we do that, we've got the limit as delta x tends to 0 of g of x multiplied by f of x plus delta x, subtract f of x, all divided by delta x. Okay, and so hopefully you can kind of see already what's going to happen here. And now again I can distribute this limit even more, so I could say this is equal to the limit as delta x tends to 0 of f of x plus delta x multiplied by the limit as delta x tends to 0 of g of x plus delta x, subtract g of x, all divided by delta x. I can then, let's put this in square brackets maybe just so it's very clear. Then I'm going to add on the limit as delta x tends to 0 of g of x multiplied by the limit as delta x tends to 0 of f of x plus delta x minus f of x, running out of space, all divided by delta x. Okay, so now we can actually work out these limits. Well, in the limit as f of x plus delta x, in the limit as delta x goes to 0, I'm left with f of x, so let's write that in. We've got f of x. That's multiplied by this limit here as delta x goes to 0. And that is our formula for differentiation from first principles. So that will give me the first derivative of g of x, so multiplied by the first derivative of g of x. I'm now going to add on the limit as delta x goes to 0 of g of x. Well, that's just g of x, so I'm going to add on g of x. And that's multiplied by the limit as delta x goes to 0 of this thing here, which is again the formula for differentiation from first principles. So I'm multiplying that by the first derivative of f of x. And so there we get that the derivative h dash of x is equal to our product rule formula. And you can actually extend this if you've got more than like two products. If you had h of x equaling f of x multiplied by g of x multiplied by say like I of x or some other function. And so yeah, that's pretty much the proof. I hope you found it useful, and if you did, like, subscribe and share, and go over to my channel for tons more maths tutorials. Thanks for watching.